So in talking the Earth's atmosphere, we talked about how it gets thinner with altitude. Well, there's other factors that are going on here. And well, it turns out the atmosphere has layers. So the lowest layer of the atmosphere we call the troposphere. Above that's the stratosphere, then the mesosphere, the thermosphere, and then we have the exosphere above that. We'll talk about that later. So let's explain a little bit about what these layers are and what makes them different from one another. So we'll start with the troposphere. The troposphere is the lowest layer of the Earth's atmosphere. What's going on with the troposphere? Well, it contains about 80% of the atmosphere. So describing the Earth's atmosphere means you have to describe the troposphere. This is where all the weather occurs. This is where the climate, this is the key to the climate of the Earth. Now, what happens in the troposphere is that the higher that the sunlight passes through the atmosphere. So imagine that we've got the surface of the Earth, okay, and we got sunlight passing through the atmosphere, heating the surface. And so that you heat the air into the surface, that air rises and displaces cooler air that's above. So as it rises, the air expands, which makes it cool down. So the higher you go, the cooler the air is. So the temperature drops with altitude. You go to the top of a mountain, it's warm, it's cooler than it is at the bottom of the mountain. Go to the Grand Canyon. It's cool and comfortable at the top of the canyon, but when you hike down into the canyon, the temperature is increasing with the farther you go into the canyon. Mountaintops often covered in snow because they're higher. Where commercial aircraft fly is well below freezing. And so the higher you go, the lower the temperature. That is a characteristic of the troposphere. And so the troposphere is a layer that ranges between 7 and 17 kilometers thick. The actual thickness of it varies. You get changed atmospheric density, pressure changes. It gets higher, it gets lower. The top of it does, that is, it gets higher, it gets lower at time. It changes with seasons, changes with a variety of different factors. Okay. And it also changes with latitude. The troposphere is typically thinner near the poles and thicker near the equator. So as I said, the basic idea is that sunlight heats the ground. The warm air near the ground rises. Now, you have water near the surface of the ground sometimes, moisture, and that evaporates. And so this warm air, as it rises, is expanding. When the air expands, it cools. Now, as long as it cools, but it's still warmer than the surroundings, it keeps rising. And so that gives you convection. What happens is that when you get up to the next layer of the atmosphere, the higher you go, the warmer it is. So rising air, when it expands and cools, it's cooler than the air above it, so it quits rising. So this is why clouds occur in the lowest levels of the atmosphere, because the rising air doesn't go up that high. The cooler air is, the less moisture it can hold. So that means you have a certain amount of water in the air. If you cool the air, the relative humidity goes up. It does not mean there's more water in the air. It means the air can hold less. And so the relative humidity is simply a measure of the percentage of water that's in the air compared to the maximum it could have. Well, as the air rises, it can hold less water, and so eventually the water vapor comes out of the atmosphere. It condenses out. And so that gives rise to clouds. Clouds will occur only where this sort of circulation is occurring, and so that's only in the troposphere. Okay, I'll expand that a little bit later. There's another kind of cloud called noctilucent clouds, which occur at a higher layer of the atmosphere, but they're produced by an entirely different process. So cumulus clouds, this is your generic fair weather clouds, warming air near the ground, rises, and it makes these little puffy clouds up there. Okay. Sometimes you get clouds at the very top of the troposphere, and those clouds tend to be ice crystals because it's so cold up there. And cirrus clouds are example of these ice crystal clouds that are very close to the top of the troposphere.